So in this video, we're going to go ahead and solve those 3 unit conversion problems that were in the previous video, the unit conversion questions. If you haven't watched that video yet and you want to try those first, go ahead and watch that video and I'll introduce the 3 problems for you. First thing I'm going to do to solve this is I want to figure out my conversion factor. I'm going to go to my conversion chart, and I told you that this was a pressure. So let's look for our pressures. So right here I have pressures. I have 1 atmosphere, and I have all these units to pick from, but one of these at the bottom is PSI. And those are the 2 units I'm talking about in this problem, is atmospheres and PSI. So we'll go ahead and use that conversion, which is 1 atmosphere equals 14.7 PSI. So I'm going to go through my steps. I'm going to rewrite my problem as a fraction, 30.0 PSI over 1. And I'm going to multiply this by my conversion factor, making sure that my PSI will cancel out with this PSI. So I have a fraction here. If I want them to cancel out, then my PSIs have to be on opposite sides of fractions. So I'm going to put my PSI on the bottom here, which means that in this blank area, I have to put the other side of my conversion factor. So these now cancel out. This PSI cancels out with that PSI, meaning that now all I have to do is I have to multiply across to get my numbers. So here I have 30.0 over 14.7, and I am using atmospheres, and that's what I have. That's what I'm left with. So I know that I'm good. At this point, all I need to do is simplify. If I go ahead and plug this into a calculator, I get 2.0408 and some additional stuff. Let's use our significant figures here. My original question, my original number, has 3 significant figures. Now, the next question is, is my conversion factor perfect? And the answer here is no. I can assume that the 1 is perfect, but not that the 14.7 is a perfect factor. So therefore, this original number has 3 significant figures. This one also has 3 significant figures, which means my final answer needs to have 3 significant figures. And there's my answer. So let's move on to the next one. All right, this one has a lot more going on. I want to turn, and I forgot to update this. I changed this in the last video, so let me change it real quick. This was gallons. All right, so what we're going to do is we're going to change liters into gallons, and then calories into joules, and then slugs into kilograms. You can go to the conversion chart and you can look those up. I went ahead and looked those up ahead of time, so I'm just going to write those down. I have 1 liter equals 0.264 gallons. I have, and I'll just write it off to the side here, I have that 0.239 calories equals 1 joule. I have that 1 slug, funny one, slug, equals 32.2 pound mass. And then I have 1 kilogram equals 2.205 pound masses. So here I have 3 units I want to convert, but I need 4 conversion factors to do this because one of them takes a couple steps to do. So what I'm going to do is I'm going to turn this into a fraction. I'm going to do 27 liter calories over 1 slug. And it really doesn't matter what I cancel out first. I can cancel the slug first, the calorie first, the liter first. I normally just start on the top and start on the left. So I'm going to go ahead and do the liter first. To do that, I'm going to use my first conversion factor. To make sure the liter cancels, I'm going to put the liter on the bottom. So 1 liter over 0.264 gallons. My liters cancel. So now I can move on to something else. What else do I want to cancel here? I don't want to cancel gallons, but I can cancel my calories or my slugs. I'm going to choose to do my calories next. Calories on the top. So I'm going to find my conversion factor with calories and make sure that my calorie part of my conversion goes on the bottom. Which leaves an open spot on the top. That's where I put the rest of my conversion factor. My calorie cancels with that calorie, and I'm left with a joule. That's good. That's what I want over here. So currently I have a gallon, which is good. I have a joule, which is good, but I have a slug, so I'm not done yet. It hasn't been crossed out yet. So let's get a different color for the slugs. I'll do gray. I want to cancel out slug. Now this time slug's on the bottom. So to cancel out slug, I need to find something with the slug in it, and that is this conversion factor here. But since slug's on the bottom of my original number, I want to put slug on the top over here. 1 slug over 32.2 pound masses. My slug cancels out with my slug, and I'm left with a pound mass. I go back to my original problem, and I say I don't want a pound mass. I want a kilogram. What does that mean? It means I'm not done yet. So I got to do this again. I need to find something that cancels out my pound mass. And my pound mass is on the bottom, which means I put my pound mass conversion on the top. And I put the rest of my conversion in the other spot. And my pound masses cancel out, and I'm left with the kilogram. So at this point, before I do any calculation, I want to make sure that everything gets canceled out. So I look at all my units, everything's crossed out or circled, and the things that are circled are gallon on the top, joule on the top, kilogram on the bottom. So everything looks good. So now what I'm going to do is I'm just going to start simplifying. If I do the math here, I get 15.71724 gallon joules over 7.6958 kilograms. If I simplify this, this equals 2.0423 gallon joule kilograms. Let's use our significant figures. 4 significant figures, 3 significant figures, 3 significant figures, 3 significant figures, 2 significant figures. My final answer only has 2 significant figures, which means I write this as 2.0 gallon joules per kilogram. Now, what is a gallon joule per kilogram? I have no clue. I made it up for you guys. All right, we have one more problem that we're going to work. And it is this volume problem. All right. So here's the volume problem. We have 17 inches squared, and I want to turn that into meters squared. Now I asked you in the original problem to go ahead and solve this, but don't find a conversion that goes from inches squared to meters squared. Instead, I want you to find a conversion that only goes from inches to meters, and then we'll have to figure out how to turn that into an area along the way. So I went ahead and did that. I found that I have 1 inch equals 2.54 centimeters. This is a definition here, so it has an infinite number of significant figures. And then I have that 100 centimeters equals 1 meter. All right, so let's go ahead and work through this. And this one is actually a little bit more tricky than it looks, because what a lot of people will do is they'll turn this in and they'll say, all right, so I write my 17 inches squared, do a fraction, and they'll start canceling stuff out, and they'll find their first conversion factor, and they'll say inches, I put on the bottom. They're getting pretty comfortable here, and they'll say, all right, so I put my 1 inch down here, which means I put my centimeters up here, and then they cancel. The problem with doing this is you'll notice that on the bottom of my fraction of my conversion factor here, my inches, it's inches. In my original problem, it's inches squared. Those can't cancel. So there's actually 2 ways to go about this, and I'm going to go ahead and show you the way that I like to do it. It's not as popular as what a lot of people do. I like to show my work. I really like to see what's happening. And so what I'm going to do is I'm going to do this factor one more time. What that's going to do is we have to remember that this inches squared really looks like inch times inch. And so if I do the conversion once, this inch cancels out one of those inches or gets rid of my exponent. I'm still left with inches. So if I do it a second time, that inch cancels out my last inch. And now my inches are gone and I'm left with centimeters, but I actually have a centimeter times a centimeter, and those 2 things together are centimeters squared. So that's one way to do it. That's the way I prefer it. Shows work. I do one thing at a time to make sure that it works. I'm going to go ahead and do the second one the other way. And what we're going to do is we'll take my next conversion. I want to cancel out my centimeters there on the top. And so I put centimeters on the bottom, 1 meter on the top. I have to do it twice, and so I could write it a second time, or I could square my entire conversion factor. If I do this, I have to remember that this squared gets distributed to everything inside of here. It gets distributed to the 1, gets distributed to the meters, it gets distributed to the 100, it gets distributed to the centimeters. And so really what this turns into, if I were to write it this way, is we get that this is not there. This would be my centimeters squared over 1 meter squared. So 1 squared is 1, meter squared is meter squared, centimeter squared is centimeter squared, and 100 squared is 10,000. So now I don't have to do it twice, I've already done it twice. And one of these centimeters cancels out with the exponent, and the other centimeter cancels out with the centimeter that's last. So now when I go through and I calculate this, I get 109.6772 meters squared. That's all that I have left. I like to circle that. over everything that was on the bottom. And this equals 0.0109672 meters squared. And using significant figures, this one has 3. This one is a direct definition. There's 100 centimeters in 1 meter, which means I look at my original problem that has 2, and I write this as 0.01, and this 9 is going to round up. And there's my final answer.